Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Hi dear students, good evening all of you. Here we are going for the second session of our chemistry discussion. In the first session, we discussed about haloalkanes, haloarine chapter, even biomolecule chapter, right? Here we are discussing one of the easiest chapter, especially for MCQ and all. We can easily we can able to present the answer for this chapter, coordination compounds. I hope you all are ready. And may I know how many are there, and I hope you all are ready for the coordination compound chapter discussion. Before that, as I told you dear all, our aim is not to just discuss certain questions. We have to make a recap for the chapter because exams are very close. So what are the area, which all are the important chapter area from the coordination compounds? You know, the main important areas are, first one, you know, how to name a coordination compound, the IUPAC nomenclature of coordination compound. It can be expected as an MCQ. Second one, they give you the name, they ask you the structure or structure to name. You know how to calculate the oxidation number, coordination number, etc. Means primary valency, secondary valency and all regarding a complex. You know which all are the types of ligand, monodentate ligand, bidentate ligand, polydentate ligand, ambidentate ligand, chelating ligand, all the types of ligand with example, right? With example we have to know. And then we have to know about the theories regarding which one coordination compound. Three theories are there, you know that names: Werner's theory, VBT, valence bond theory, and CFT, crystal field theory. These are the three theories. Related questions are must for your exam, either in MCQ or in the descriptive part. Okay, and another part is the metal carbonyls, stability of coordination compound, spectrochemical series, and most of the students are forgetting to, or they are skipping the area, final part, that is application of coordination compound. Dear all, application of coordination compound is one of the most important area where lot of MCQ questions are present. Okay, especially Wilkinson catalyst, cisplatin, which metal is present in biological system. Like lot of questions are hidden in that area. Which one? The application of coordination compound. I think all are ready now. Okay, let's start. Shiny is no. Okay, yes everyone, let us begin the coordination compound chapter. Lot of around 50 MCQs we are going to discuss now within a stretch. Within 1 hour we can finish maximum question with all concepts. Once again we can revise it. So I am going for the first question. The first question is the question from 2023, the previous board exam, what they were asked to MCQ from coordination compound chapter. Okay, so I will show you the question. You try to give me the answer for that one in the chat box. Let me go for the first question. What is the secondary valency of cobalt in this complex? This is the 2023 board exam question MCQ. So can you say what is the answer for this question? What is the secondary valency of coordination, the cobalt in this complex? COEN twice, Cl twice, whole plus. You know what is the meaning of secondary valency and primary valency, right? You know, primary valency gives you the oxidation state of the metal, and secondary valency gives the coordination number of the complex of the metal, right? So what is the secondary valency? They are asking you what is the secondary valency. They are all secondary valency is nothing but what? The coordination number. The coordination number they are asking. You know what is mean by coordination number? It is the sum of, or it is the total number of sigma bond connected with the metal atom by the ligands, right? So what is the answer? Able to see that? En is a bidentate ligand. Yes, somehow. Yes, okay, Satik. So I think the answer, what is the answer we can suggest for this one? What is the secondary valency of? See, cobalt is the metal, and En, you know, it's a bidentate ligand. Ethane 1,2-diamine is a bidentate ligand. So En, one En can provide 2 sigma bond, right? One En can provide 2 sigma bond. So 2 En 4 sigma bond, and Cl, you know, it's a monodentate ligand. So total you can able to notice that total how many sigma bonds are there? Very clear. 1, 2, 3, 4, 5, 6. Yes, total 6 sigma bonds are there. Let's go with option A is the correct answer. Yes, option A, right? No doubt, Nima. Yes. So this is the previous board question. You have one more question what they were asked in the 2023 board exam question. Wait for that one. What is the answer for this question? Here which I said, maybe they give you the structure or they ask you the name or opposite. So here they are asking what is the formula of the complex dichlorido bis ethane 1,2-diamine platinum 4 nitrate. Which is the correct compound? Can you say? Can you say the answer? The formula which is correct with this compound is what is the formula of the complex? What is the formula of the complex? Those who are present in the online, you can say your answer because you are going to face these type of question very soon. Within 2 weeks you are going to approach these type of MCQ for your board examination. So Nima, that's answer you are expecting. Okay, one answer is ready. Let us any other answer? Any other answer? What is the formula of this complex? They are all dichlorido. What is that? Dichlorido means Cl2, 2 chlorine. Bis ethane 1,2-diamine, that means En twice, right? En twice. Bis ethane 1,2-diamine, En twice. Okay. Then what is the metal? Platinum. That is what? Pt. Okay, Pt. Coordination sphere is okay. And what is outside? That is nitrate. What is nitrate? NO3. Okay, NO3. So the question, overall, you know, overall oxidation state, we have to get it as 4. So what we need to do here? You know, as per this formula, platinum X, 2 chlorine minus 2, En is a neutral ligand, and NO3, you know, nitrate charge is minus 1. Overall, if it's neutral, you will get it as plus 3. But you want plus 4. Yes or no? So what is the adjustment? What is the adjustment we can do it in order to make the oxidation state as plus 4? Dear all, we know the ligands we can't interchange, or ligand number we can't able to alter. Only one thing, the counter ion if there, that number we can adjust. Let me put NO3 twice. Why? Because if it is NO3 twice, it will be minus 2, then overall it will be plus 4, right? So PT, Cl2, En twice, NO3 twice. Yes, Nima, that's a correct answer. Option B is the correct answer. Option B is the correct answer. All of you, please careful about this one. Okay, those who made mistake, no problem. I think most of them given the correct answer. So keep watch it, keep doing the question. Whenever we showing a question, be ready with a book and pen. Try to find the answer. That answer you comment in the chat box. If there is any mistake happen, no problem. Try to correct. Don't do the mistake in the main examination. Okay, so these are the two previous 2023 board exam paper they were asked. So we are going for the upcoming examination, for your examination 2024, this month examination, what all type question we can expect for our examination, that we are going to start now. Okay, dear all, coordination compound chapter, 7 mark easily we can able to score it, dear all. Especially for theory area, let me focus. Theory area, descriptive type of question, whether they ask VBT, CFT, these are sure question, okay. VBT, the structure, shape, geometry, inner or outer, low spin or high spin, para, dia, colored or colorless, all type of question we can expect from VBT, okay, careful. So I am going for the next question, FAC and MER isomer, dear all. Last year they didn't ask any question from especially the question from the isomerism part. This year we can definitely expect a question from isomerism part. Come on all of you, my dear students, tell me what is the answer. FAC and MER isomerism is associated with which type of compound? FAC and MER isomerism associated with which type of compound? Come on, which one? Mushfiq already given the answer, that is B. And Satvik given B, Aditya given B. I think most of the students, Nima, Abu, Nachi, all are going for option B. Yes, dear all, the one with the MA3B3. You know the one with the MA3B3, it will show what? FAC and MER isomer. You know the arrangements and all, right? What is mean by FAC, dear all? A, B, B. You know the A ligands when you connected, you will get a facial, right? This is called what? FAC facial. And what about meridian? A, 1A below, you will get a meridian isomer, that is MER isomer. So with the type MA3B3, very good all of you. Yes, Karthik? Yes, Satik, correct answer. So MA3B3, all of you fix in your mind. MA3B3 type shows FAC and MER isomer. Same type of question, same concept I will show you in another pattern, in another mode in the upcoming questions. Here is a simple question for your exam. These are the type of question they are frequently asking in MCQ area. Tell me, dear all, what is the answer? Very fast. The complex, these two complex shows which type of isomerism? Immediately, within second, I hope you can able to answer this question. What type of isomerism given by this complex? Arnav, Nima, Satik, again all are going with option B. Yes, why you said linkage isomerism, sir? Linkage isomerism is the correct answer. Yes, dear, your answer is correct. What is the reason? You know that. When I say this question, hope you all think about that. Yes, there is an ambidendate ligand. Am I right? Yes. So here NO2, you know NO2 is called nitro or a nitrito N, and ONO, what we call it as nitrito O. So NO2 and ONO, they are what? Ambidendate ligand. You know, ambidendate ligand present or ligand present, what they shows? They shows linkage isomerism. No doubt option B is the correct answer. Yes, dear all, ambidendate ligand, that area you may revise, dear all. So while doing this MCQ, please connect with our theory part also, okay? So don't waste your time, effectively utilize this time for your exam. Next question, again isomerism, because this isomerism question mostly expect in this year in your question paper. Which type of isomerism is shown by the complex of this compound? Very careful, okay? Sometime they will give you some complexes, sometime they may not show any isomerism. That also we should be careful. The molecular formula correct or not, please check in both of the compound. Okay, so what type isomerism? I'm sure all of you have a correct answer for this one. Yes, my dear students, all are going with option A. Good, option A is correct, because here bromine and sulfate is interchanged. You know, one of the ligand going outside as counter ion and the counter ion coming inside as ligand. You know, this isomerism or this exchange from inner to outside, outer to inside, what it is called? Ionization isomerism. Yes, good. Option A is the correct answer, dear all. Option A, Karthik, Shaza, Mushfiq, Ruben, Satik ji. Okay, yes, all are given option A. Next question for your exam is primary and secondary valency of platinum in this complex is. This is the same type 1 question I show you in the first slide. They asked the previous year question. Primary and secondary valency of platinum in this complex is. Dear all, it's actually dealing with this small numbers, dear all, right? So plus 1, minus 2, 0, but still there is a chance to make mistake. Please don't do that. Please don't do that. Okay? Please don't be like more, yes, I can able to answer immediately, like overconfidence. Please don't do it here because it's a small numbers and all. There is a chance to make mistake. Be conscious about this question. So first one, primary valency. Note it all of you. Primary valency means oxidation state. Secondary valency means coordination number. Answers are there. Okay, let me clarify. What is the oxidation state of platinum? Platinum X. En is neutral ligand. 2 chlorine minus 2. Overall it's neutral. Yes, oxidation state is plus 2. Oxidation state 2, that is only one answer, option D. Anyway, what is the coordination number? See, platinum connected to En, you know, two En provide 4 sigma bond and Cl, yes, total 6 sigma bonds. Option D is the correct answer. Maybe they ask you the questions like this way. By giving a complex, they will ask you, what is the sum of primary and secondary valency? That also one question. What is the sum of secondary and primary valency? Sum means 2 plus 6 what? 8. But we won't care about. That's why that's everything happen. Those simple mistakes are happen due to our tension. Due to our tension. Dear all, no need of any tension in chemistry examination. It is normal. It is normal exam. Every time, every year, there is a general pattern for examination. Not at all worry about this one. If this kind of tough numericals comes or not. No, there is a general pattern. You go with your NCERT. Answers are there. Your mark is already fixed. Let's go for the next question. What is the IUPAC name of the given compound? Come on. What is the IUPAC name of this given compound? Come on. Satvik, that EDTA, 1 EDTA charge is minus 4. 1 EDTA charge is minus 4. And it is a hexadentate ligand, we know, right? Come on all of you. Sri Krishna, yeah, Karthik, Satvik, okay. Karthik already given, the answer is option C. Karthik already given C, Abu C, Aditya, okay, Hanna B, Nima C, okay, fine, Anna C, okay, Mushfiq C. Okay, I think most of you are going with option C. Let me check it all of you. You know, this is called the ligand amine. This is bromido. This is nitro or nitrito N chlorido. I know alphabetical order, no doubt, amine first. So triamine, bromido, nitro or nitrito N chlorido. Where it is? I think from there itself you will get it. Triamine bromido. Yes, option C. Triamine bromido. I think other options are given triamine chlorido. You know, bromido, chlorido, if it comes alphabetical order B first, right? Bromido should come first. That's enough to get the answer. And overall oxidation state here all, amine 0, bromine minus 1, NO2 minus 1, chlorine minus 1, chlorine minus 1, total minus 4. It will go to us what the right side, it will get you plus 4. Yes, that is already the answer is given. Let's go with option C. Next question, which of the following has square planar structure or DSP2 hybridization? Here's some ideas required. Those who are practicing the questions by writing and all, they can immediately, you can able to say by applying some concepts. Which of the following has square planar structure or DSP2 hybridization? Come on. Who can give the answer fast? Let me check. Yes, good Abu. Good. Already got the answer within second. Nima, good. Yes, Abrar, okay. See, dear all, that's why we are conducting this MCQ session. You know, MCQ session means it's a do or die type of questions, you know. There is no second chance to correction, okay, because once you wrote, okay, you can correct it, it's not an OMR sheet or something. You can correct it, but the final answer, you should be you should be guaranteed about these answers, okay, because 1 mark 1 mark, we should not lose it because of silly mistakes. I think, dear all, let me tell you, nickel, first option, you know, chlorine is a weak ligand. Chlorine is a weak ligand, so the d orbital, I think the electrons won't be free. So it will start from sp3. It will start from sp3. It will go to tetrahedral. So option A, we can cut it. Most of the students are given the answer. Manjunatha, Karthik, okay, all are given option C. Yes, option C is correct. What is the reason? You know, nickel, you know, atomic number 28. So what is the configuration? You know, argon 4s2 3d8. Here nickel oxidation state, while calculating you will get 2 plus, so this 2 gone, what is left? 3d8. Alright. And cyanide is a strong ligand, dear all. Cyanide is a strong ligand. So strong ligand present, you know how 8 electron exist? 2, 4, 6, 8. They get paired. So you have this is 3D, this is 4s, and you know this is 4p. You know, total 4 ligands are there. So 4 orbital, we need to take it for the hybridization. So what is that? dsp2. Yes, it is square planar geometry. Option C is the correct answer. Okay, option C is the correct answer. Why not option B? Dear all, option B, CO, carbonyl is also strong ligand, but you see here nickel oxidation state is 0, so these 2 electron will come inside. That also d orbital not available. You know, square planar mean we should start from D. At least one d orbital should be free, then only we can go with which hybridization? dsp2 hybridization. My dear students, answer is option C. Are you ready for the next question? Do you want more question or not? Do you want more question or not? Do you want more question or not? Can you comment in the chat box, all of you? Do you want more question? Yes? Yes, lots of different types of questions are ready now. Yes, let's go for the next question. What is the geometry and magnetic behavior of the complex NiCO4? Tell me, what is the geometry and magnetic behavior, whether para or dia, for this complex? Come on, dear all, come on. What is the I already discussed this NiCO4 in the previous question. NiCO4 will go for sp3 hybridization. Yes, nickel, you do it, okay? You do your answer and comment in the chat box. I'm doing one side. Nickel 28, so configuration is 4s2 3d8. Here nickel oxidation state is 0, so excited state is not there. Let's go for this. Carbonyl is a strong ligand. Strong ligand means, you know, this 2 and this 8 all come inside, and it will be total 10 electron. They will occupy like this one. Yes, it will go to the hybridization. What? sp3, right? sp3 mean what structure, dear all? Tetrahedral geometry. No unpaired electron, therefore they are diamagnetic in nature. So let's go with option tetrahedral and diamagnetic. I think you are already given the answer B. Is it B or not? Is it B or not, dear all? Tell me. Is it B or not? Venkata, it's B, right? Nima, Nachi, is it B or not? Do you have any confusion? I think different answers are there. I think the route is correct. Ground state, you write it. There is no excited state. So directly take the hybridization, what? sp3, that is what? Tetrahedral geometry. Okay? Yes, it is correct. Option B is correct. Alright, dear all. Next question. What is the IUPAC name of the complex? Quick. For this type of question, we won't waste enough time. Come on fast. IUPAC related one question you can expect either in 2 mark area or in MCQ question, sure. What is the IUPAC name of the complex FeCN63 minus? Very fast. Hexacyanido ferrite 3 ion. Hexacyanidoferrate 3 ion. Yes, very good. Option C is the correct. Hexacyanidoferrate. You know, if the metal is present in anionic part, it will end with 8. Ferrate. Right. Hexacyanidoferrate 3 is the oxidation state, and ion. It's an ion. So we are ending with ion. Hexacyanidoferrate 3 ion. Option C is the correct answer. Cyanato. No, cyanato we won't use it not for the cyanide one. Cyanide normally we are using cyanido or cyano. Cyano or cyanido. So that's a best correct answer. The best suitable answer is what? Cyanido. That's the one. Okay. Next question. Which of the following is a hexadentate ligand? You have a quick answer. You have a quick answer for this question. Which of the following is a hexadentate ligand? You are studying in NCERT. Which of the following is an hexadentate ligand? Yes, Shaza, Sati, Karna, Hanna, Venkita, all are given. That is option A, no doubt. EDTA. Yes. What is EDTA full form, dear all? Ethylene, right? What is EDTA stands for? Ethylene diamine tetraacetate, ethylene diamine tetraacetate. This is what, dear all? EDTA. This is what we call EDTA. What are the nucleophilic part? This all negative part, and the nitrogen carry lone pair. See, total there are 6 sites to attack a metal. So what is the name? It is a hexadentate ligand. Very good, Nachi. That is ethylene diamine tetraacetate. It's a EDTA. Can I ask you another question? What we can expect for the upcoming exam? Dear all, those who are in online, please listen the question. My question: in order to form an octahedral complex, I'm repeating once again. In order to form an octahedral complex, how many EDTA are required? Come on. In order to prepare an octahedral complex, how many EDTA are required? Can you say the answer? In order to prepare an octahedral complex, how many EDTA are required? Venkita, yes, correct one. Only one is enough. Only one, because one EDTA, octahedral complex mean coordination number is 6. One EDTA, see, one EDTA are giving 6 sites. So one EDTA is enough to what? To make one octahedral complex. Okay, so that point also, yes, please keep in mind. Yes, correct, Nachi. Next question, dear all, more salt is, come on. More salt is, you may study it in NCERT. What is the difference between a double salt and a coordination compound? More salt, you may study it in analytical chemistry. Your practical chemistry also, you are studying what is more salt. More salt is a double salt. More salt is a double salt of what? Ferrous sulfate and ammonium sulfate. What is that? More salt is a double salt of what? Ferrous sulfate. Very good, very good. Ferrous sulfate, ammonium sulfate with 6H2O. Yes, more salt is double salt. Its formula is option B. Yes, yes, dear all, very good. Option B is the correct answer. Next question, tell me all, which is the correct answer? According to Werner's theory of coordination compound, which is correct? Come on. According to Werner's theory, which one is correct? According to Werner's theory, which one is correct? According to Werner's theory, which one is correct? Which one is correct? Very good. You may study that primary, according to Werner's theory, 2 type of valencies are there for a metal. Primary valency and secondary valency. Primary valency gives the oxidation state and secondary valency gives the coordination number. Primary valency is also called ionizable valency. That is a point. And secondary valency is also called what? Non-ionizable valency. Okay, dear all. So primary valency is ionizable. Yes, A is the correct answer. Yes, John, Mushfi, Karna, Venkita, Arjun, Satik, Karna. Okay, yes, all are given the correct answer. I think the theories are very perfect with you. Let's go for more question. Which one of the following is an outer orbital complex and exhibit paramagnetic behavior? Outer orbital complex mean hybridization, sp3d2. Tell me, dear all, which complex can show sp3d2 hybridization, outer orbital complex? Come on. Which of the following complex can show? If you give an answer means I can proceed with that compound. Can you please help me? Which one of the following is an outer orbital complex? Whether it will show, it has to show sp3d2 hybridization. Which one? Which one can show sp3d2 hybridization? Okay, one suggestion, that is option C. Then one suggestion is option C. Okay, Fahad, that's option B. Okay, option C. Two answers I am getting now, B and C. Okay, let me go with the B and C. Okay, B, let us check it first. B is cobalt. You know, cobalt atomic number is 27. So you will get argon 4s2 3d7. I think cobalt here the oxidation state is 3 plus. So these two gone, it's 3d6. Alright, and amine is a strong ligand. Strong ligand means electrons undergo pairing. So 6 electrons get paired. Dear all, I think this is not sp3d2. See, 2 d orbitals are free, no? So it will start from d to sp3. It will go to inner orbital complex, right? So option B is not correct. And another suggestion is given as option C. Okay, let us check it. Option C is nickel. Nickel is 28, that is 4s2 3d8, and nickel here oxidation state is 2 plus, this gone, that is 3d8. All right, and it says amine is a strong ligand. Amine is a strong ligand, so we are expecting all the electrons get paired. Dear all, nickel, one exceptional case we studied in class. Nickel, one exceptional case is there. What? d8, right? 8 electron if it pair, you can do like this, 1 2 3 4 5 6 7 8. Then 1 d orbital only free. You already know its coordination number is 6, so it should be an octahedral. Octahedral mean either sp3 d2 or d2 sp3. Am I right? So dear all, if you pair, you know, amine is a strong ligand. So if amine is a strong ligand and if you pair it, what happen? Only 1 d orbital is free. 1 d orbital free, such a hybridization not in what? Octahedral. So even though it's a strong ligand with a nickel, dear all, we should not pair it. We should not pair it. So let me take 1 electrons here itself. Then we will go for which hybridization? sp3 and last 2 d orbital sp3d2. Yes, correct answer is which one? Option C is the correct answer. So dear all, nickel case, be careful. Nickel case, be careful dear all. Even though there is a strong ligand, you may study in NCERT, there is a question, why nickel do not form inner orbital complex? Nickel do not form d2 sp3 hybrid orbitals generally, right? Why? Because even after pairing, only 1 d orbital is free. At least 2 d orbital should be free, then only it can show d2 sp3. So careful, nickel complexes generally do not show what? Inner orbital complex. It will show always what? Normally sp3d2 hybridization. Your answer is option C. Okay dear all, please try to correct it. Next question, the oxidation state of nickel in this question. 1 minute. 1 minute not needed. I think 2 seconds is enough. 2 seconds. Only the thing to just read the question option. What is the oxidation state of nickel in this complex? Quick answer. Very quick. Very quick. Already we discussed this compound many times. What is the oxidation state of nickel in this complex? What is the oxidation state here all? What is the oxidation state? Very careful. Very careful. It's option A, 0. You know, nickel X. Carbonyl, CO is called what? Carbonyl ligand. Carbonyl ligand is neutral. Neutral, and overall charge is also neutral. It's 0 oxidation state here all. Option A. Don't think always it's positive. Certain cases metal oxidation state can be 0, but we can guarantee it won't be negative. Metal oxidation state either 0 or positive should come. Yes, all are given correct answer. Yes, Nachis, no. Okay, Gita, okay, Satik, yes, correct. Yes, next one. This ligand is, whether it is bidentate, tridentate, tetradentate, pentadentate, which one? What is your answer dear all? If they given a unknown ligand, how can we understand what is the denticity of the ligand? It is given as NH2, CH2, CH2, NH2. Ethylene diamine is given. You know this ligand. It's a non-ligand. What is this ligand? Ethylene diamine. That is our EN ligand. En is what type ligand? It's a bidentate ligand, right? It's a bidentate ligand because the lone pair on nitrogen, yes, it will give to metal. 2 is the coordination number. Density is 2. So dear all, this is our the En ligand, ethane 1,2-diamine or ethylene diamine. It's a bidentate ligand. Yes, we are going for the next question. Among the following, which are ambidentate ligand? Which one? Come on. Among these following, these are very quick answer you can give it, my dear students. Dear students, don't make any mistake. Among the following, which are ambidentate ligand? Which all are ambidentate ligand? Come on. You know, ambidentate ligand we studied 3 set. That is cyanido, isocyanido, thiocyaneto, isothiocyaneto, nitrito N and nitrito O. Which one? Yes, thiocyaneto. Nitrato is not there. NO2. Yes. SCN minus and NO2. That is 1 and 3. 1 and 3. 1 and 3. Option A. Option A. Yeah, no problem. Don't make mistakes. Now okay. Now it is studying time. Now it is a revision time. Okay, during exam, don't make mistake. Let's go for the next one. A coordination compound CrCl3,4H2O give a white precipitate of AgCl with a silver nitrate. The molar conductance of the compound correspond to 2 ions. The structural formula of the compound is very simple question, a good question. Can you say which complex is the answer? Which complex? A coordination compound CrCl3,4H2O. CrCl3,4H2O. That is a molecular formula of the complex, which is giving a white precipitate. Which one? Which one? Where is the answer? Where is the answer? What happened? What happened, my dear students? Do you feel any difficulty in this question? Very simple, okay? Very simple. Don't leave it. Don't leave it. Very simple question. Yes, my dear students, very good. Here, the CrCl3,4H2O. First question you see, dear all, CrH2O already given, their complexes are given. Then what's the doubt? See, this first compound H2O, third compound Cl, fourth compound Cl2. Question, a coordination compound is giving white precipitate of AgCl. If you are getting a white precipitate of AgCl, meaning is there is some chlorine outside. There are some chlorine outside, because on counter ion only can undergo what? The precipitation reaction. So here no counter ion, here water is the counter ion, it won't give AgCl. So only option 3 or 4 is correct. And they give one more choice. It will give you 2 ions. Tell me what are the ions given by this complex, dear all? This complex will give you CrH2O 4 times Cl2 plus and Cl minus. It will give you 2 ions. Yes, that is our answer. Option 3. Option 3. What about this complex? This complex breaken CrH2O 4 times Cl2 plus and 2 Cl minus, total 1 plus 2. It will give you 3 ion. No, option 3 is the correct answer. So let me clarify one thing. If they are saying AgCl formed means there are some chlorine outside. There are some chlorine outside. Okay. So answer is option 3 is the correct answer. Very good, dear all. Yes, I hope you are understanding. Yes or no? Yes or no, dear? Are you getting the concept or not? Are you getting the concept or not? Yes, my dear students, come on, fast. Are you getting the concept or not? Time is very less. Time is very less. Yes. Okay, next question. Identify the statement which is not correct. Come on, read all of you. Read thoroughly. Identify. Very good. Thank you all of you. Yes. Keep reading questions. Pradi, Risha, Mushfiq, Nachi, Venkata, Nima. Yes. Identify the statement which is not correct. Come on. Read quickly and be ready with the answer. Identify the statement which is not correct. Krisha. Coordination compounds are mainly known for transition metal. You know, transition metal our D block. Yes, nickel, cobalt, chromium, manganese, iron. These all are what? D block element. Yes, coordination compounds are formed by our transition metal. Even D block chapter you studied why transition elements form coordination complexes. That's a correct statement. Which is incorrect, my dears? Which is incorrect? Yes, option 2. Why doubt? Why there is a doubt? Correct. Option 2, coordination number and oxidation state of metal are the same. It's not compulsory. It is not compulsory. You may have seen that oxidation state is different, coordination number is different. It should not be the same. It can be same, but not for all compound, for a few compound. Yes, option B is the incorrect statement. That is our correct answer. Let's go for the next one. Yes, dear all, the coordination number, again, coordination number and the oxidation state of the metal E in the complex is. Come on fast. What is the coordination number? What is the coordination number and oxidation state with the metal E? There is En, 2 En are there, okay. And what is C2O4? You know, C2O4 is our oxalate, right? Oxalate also provide 2 sigma bond, total 6 sigma bond. So coordination number is 6. And what is the oxidation state? Ex, En is neutral and oxalate is -2, NO2 is also -1, so overall 0, X equal to +3. Coordination number 6, oxidation state is 3. I think the option you given as number 1. Yes, Risha, correct. Yes, Arnav, yes, Anna. Yes, option 1 is the correct answer. Coordination number 6, oxidation state is 3. Let's go for the next one. Dear all, this is another tricky question. Tricky in the sense, simple one, a small tricky question. The charges X and Y, you can able to see XY given ion. What the oxidation state of cobalt is +3 and iron is +2 in their respective complex is. See, they given cobalt NH3 twice Cl4 with a charge X. Another one is FeCN6 and overall charge is what? Y. What is this value? X and Y. See, already they given cobalt oxidation state overall should be +3 and iron it should be +2. What it is? Just a substitution. Just a substitution. What it is, dear all? You can take in different way. Either you can cobalt, you can substitute +3, or let me take cobalt X, amine neutral, 4 chlorine -4, overall charge is X. So overall charge of cobalt I want to get +3. If I want to get overall charge +3, see, as per this I will get, as per this X is cobalt, okay, this cobalt one I am expecting, cobalt. So cobalt, what is the oxidation state? As per this one, you will get +4. As per this, if X is 0, you will get +4. If you want to get +3, what should be the value of X? I think the X should be -1. If X is -1, this 4, if it go to the right side, you will get +3. Yes or no? So -1 is the value of what? X. And what about this case? Take it iron, the iron oxidation state plus, and cyanide, 6 cyanide -6, overall is Y. And overall, so as per this, you will get Fe. If suppose Y is 0, at 6 go to the right side, you will get 6. But they said iron oxidation state should be overall +2. Overall +2, if you want to get, what should be Y? It should be around -4. If Y is -4, the 6 come to the right side. Yes, -4 plus 6, you will get it as what? 2. So X can be -1, Y can be what? -4. That is option C. Or directly you can substitute with the Fe, cobalt charge what? +3 here, and Fe charge what? +2 here. Yes, I think you got the answer. Option yes. Option C is the correct answer, my dear students. Let's go for the next question. In platinum, in PtCl4 to HCl has a secondary valency 6. How many moles of AgCl will 1 mole of the compound precipitate with the excess AgNO3? Come on. A good question. Give me what is the correct answer. Read question carefully. Take time. Read the question carefully. Give a correct answer. PtCl4 to HCl. This is the formula. What they said? It has a secondary valency of 6. Secondary valency means coordination number. See, dear all, Pt. Already Cl4 is there, right? Already 4 chlorine is there. And from 2 HCl, chlorine, chlorine is the ligand part, right? So this 2 chlorine also can connect. The total 6 coordination number you can make it. how many moles of AgCl will 1 mole of the compound precipitate with excess AgNO3? We already discussed that if they are treating with the AgNO3, they will form AgCl, means there should be some chlorine outside. Am I right? So here, what is the complex actually? PTCl6, right? PTCl6, because already they said that 6 is the coordination number. If it want to be 6, there should be 6 chlorine, hydrogen H plus, it won't act as a ligand. So what is the answer, my dear students? What is the answer? Question, how many moles of AgCl will 1 mole of the compound precipitate? No AgCl, because there is no chlorine outside. There is no chlorine outside, so we can directly go with option number 1, 0 AgCl formed there, because there is no chlorine outside. Are you clear? I hope it's clear, dear student. So PTCl4, so 4 chlorine already there. Why we taken 2 more chlorine here? Because they already said coordination number is what? 6. Therefore I taken 2 more chlorine. Hope you clear the question. Question number 25. Come on. What is the sum of oxidation state? What is the sum of oxidation number of cobalt in this complex and this complex? Come on. What is the sum of oxidation number? Don't make mistake, okay? Don't make mistake. What is the sum of oxidation state in this complex? First complex, I think cobalt X, H2O neutral, cyanide -1, En 0, overall +2. I think X is equal to +3. Second question, cobalt X, bromine -2, En 0, overall charge +1. So X is equal to what? +3. +3, overall what? 6. Option D, right? Option D, right? Yes, good. Karthik. Yes, dear all. Yes, Arnav. Yes, Shazza. Yes, Nachi. Yes, correct. Option 4 is the correct answer. 6. Next question. Which of the following compound has enantiomer? Which of the following has enantiomer? You studied what are enantiomer. You studied already what are enantiomer in our haloalkane chapter. What are enantiomer? They are mirror images. They are mirror images, but non-superimposable. Non-superimposable. Which one? Or which one can show an optical isomerism? Which one can show an optical isomerism? Come on, which one? Dear all, no doubt optical isomerism in order to give, it's a monodentate ligand, bidentate ligand. Check it all of you 2-3 times. If it is there, it can show. I'll show you that. Here, aluminium is the central atom, right? Aluminium connected to what? Oxalate. It's a coordination number is 6. We can plot like what? OX, right? It's an oxalate ligand. OX. See, if you take the mirror image of this compound, it will be another one, and it is non-superimposable. Dear all, in order to show optical isomerism, or in order to show enantiomerism, in complexes you can easily find from the option, that is, if the complex contain 2 or 3 identical bidentate ligand. See, oxalate is thrice, maybe En twice, En thrice, OX twice. These kind of complexes is they given. Check the mirror image whether they superimposable or not. If not superimposable, yes, they can show enantiomerism. Dear all, answer is option number 2 is the correct answer. Okay, next one. Which of the following compound does not have a coordination isomerism? Come on. Good question, don't make mistake. Which of the following compound does not have a coordination isomerism? You know what is coordination isomerism? The ligands are interchanging. Which one cannot show? It's a very simple question, but we should be careful. Which of the following compound cannot show coordination isomerism? Please don't make mistake, my dear students. Please give a correct answer. What it is? Come on. Option. Okay, one answer I'm getting option 1. Option 2. Option 1. Dear all, I will go with option number 1. Why? Dear all, have you noticed The metals are similar here. This is Ag, this is also what? Ag. See, this is chromium, cobalt, zinc, platinum, copper, iron. See the metals, right? They will interchange. So same metal means how they can show the isomerism. So option A is the correct answer because the metals are same. They cannot show what? They cannot show, because even if you change Cn here, NH3 here, this is same compound, right? Same compound, right? So metals are similar mean, or ligands are similar mean what? They cannot show this coordination isomerism. Next question, identify the correct name of this complex. Come on. What is the correct IUPAC name of this compound here all? Come on. No problem. Okay, no problem. You make mistakes now. Not purposefully, okay, it will be happen, no issue, but it will be, we can able to correct this mistake in the main examination. Come on dear all, what identify the correct name for K3FeCN6? What is the name? Potassium hexacyanidoferrate 2 or potassium hexacyanoferrate 2. My dear students, I already given, or you already given the answer. Potassium hexacyanidoferrate ferrate 3, right? Yeah, ferrate 3, because 3 6 here. Yes, while calculating 3 potassium 3 FeX 6 cyanide minus 6, overall charge is what? Plus 3. Yes, correct answer option 4. You won't make any mistake. Yes, very good. Next one. Which of the following compound has a meridional isomer or mer isomer? Mer isomer. Which one show mer isomer? Quick answer, nothing to worry, nothing to make mistake here. Which of the following compound has a meridional isomerism? You studied FAC and mer isomerism is given by the type MA3B3 type. MA3B3 type will give this one. Which one is MA3B3 type? I think you will go with option 2. Yes, right? Yes. Okay, option 2, because there are three ligand, they will show FAC and mer isomerism. Dear all, next question waiting for you. Determine which of the following statement about VBT is incorrect. Dear all, postulate based question they will ask you. Postulate based question they ask you. VBT, which is incorrect. I'm keeping quiet now. I'm waiting for your answer. B. Okay, you are saying that is option B. Okay, what is B? It can distinguish between strong and weak ligand. Yes, it is incorrect. Strong ligand and weak ligand idea is given by which theory? That is crystal field theory, not by VBT. Very good, dear all. So study the theory carefully. Postulates, demerits you can expect for even for your descriptive type of questions also. So don't forget. Next one. Which of the following is the coordination entity in this complex? Come on, 1, 2, 3, 4, 5 second, finish, answer. Which of the following is the coordination entity? Coordination entity mean the coordination sphere. What it is? Simple question. Coordination entity mean coordination sphere. What is the coordination sphere? ZnOH4. Yes, that is option D. Option D. Dear all, maybe some students may not know what is the name. Careful about the NCERT. Okay, read NCERT. Coordination entity mean coordination sphere, the square bracket with metal and ligand. Okay, next question. Which of the following cannot act as a ligand? Come on, quick. Which of the following cannot act as a ligand? Which one, dear all? Come on, fast. Which one of the following cannot act as a ligand? Ligand can carry the charge either negative or neutral. It cannot be what? Positive one, right? As per NCERT, that is they are. But NCERT, nickel 2 plus, it can act as a metal. It cannot act as a ligand. Option A is the correct answer. Yes, dear all. Good. Next question. Which of the following will not give test for Cl minus with silver nitrate? I told you, if they're not giving chlorine, AgCl or something mean there is no chlorine outside. In which complex there is no chlorine outside? Tell me fast. among this compound, see they are saying that these compound when they treated with the silver nitrate, they are not getting AgCl. That means there is no chlorine outside. Which one? Which complex there is no chlorine outside? No chlorine outside. No. I think you got a mistake. Which of the following will not give test here all? Yes. Yeah. Okay. Now correct. Yes. I think you all are giving option C, right? Yes. Very good. Because cobalt, strongest ligand in amine and chlorine is amine. So NH3 3 time and Cl also 3 time. Maximum coordination number of what cobalt and all what 6. So maximum we can occupy. There is no chlorine outside. So we can able to say C cannot give any test with what? Silver nitrate. Yes, dear all. Very good. Keep going. Next question. Which of these statement about this is true? Come on, I'm doing from my side, so you do more than before I'm getting to the answer, you should be ready with the answer. The compound is cobalt. Cobalt atomic number is 27, so 4s2 3d7. Cobalt charge here it is 3 plus, so these 3 gone, 3d6 left, and the Cn is a strong ligand, so strong ligand means 6 electrons get paired. Okay, then I have the hybridization. I will have the hybridization 6 here, so 1 2 3 4 5 6 hybridization is D2sp3. all right, so D2sp3 means it has 4 unpaired electron. No, it has no unpaired electron here, no unpaired electron, and it is D2sp3. D2sp3 means what? Low spin complexes. I think you are given the answer C. Yes? Yes or no? Okay, so be on topic. Okay, be on topic, all of you. Don't deviate from the topic, all of you. Be on the topic and be careful about the question. So I think here cobalt, there is no unpaired electron, no unpaired electrons here, and it is D2sp3 mean which one? Low spin complexes. I think the option is C is correct. Yes, good. Next one, the correct order of the stoichiometry of AgCl formed when silver nitrate in excess is treated with the complex. Dear all, first complex is given as COCl3 6NH3. Can you make a complex here all first? Cobalt is the metal. First of all you have to bond with the strong ligand. NH3 is a strong ligand. NH3 6 time and 3 chlorine will be outside. 3 chlorine outside will give you 3 AgCl. And second complex is COCl3 5 NH3. So CO will combine with all those 5 NH3 and 1 chlorine we can put it inside because maximum coordination number inside is 6 and 2 chlorine outside. So 2 chlorine outside mean it will give you 2 AgCl. And what about the last one? This complex if you are taking this cobalt NH3 4 time and already 4 amine is there, so 2 chlorine inside, 1 chlorine outside. Total maximum ligand, the capacity, make it all of you 6. Okay, so 1 chlorine outside mean it will give you 1 AgCl. So 3 mole, 2 mole, 1 mole. So 3 2 1, 3 2 1. Option B is the correct one. Smriti given the correct answer. Good, all of you. Good. Okay, option 3 is the correct answer. Next question for you. The correct increasing order of wavelength of absorption in visible region. Let me tell you the ligands once again. This is what? H2O, and this is what? En, this is what? NH3. They are asking the wavelength, increasing order of wavelength. Wavelength, how it's related with the energy. Crystal field splitting energy. Energy is higher means least to the wavelength. They are indirectly asking you which is strong ligand, weak ligand, the spectrochemical series. Dear all, tell me. En is strong ligand. Then amine, then we have a H2O. This is energy order mean opposite is the wavelength order. So water, then amine, then En. I think you already given the answer. Anyone given the correct answer? Can you tell me, dear all? Can you tell me the correct answer? Dear all, this is energy. They are connecting with the our spectrochemical series. Okay. En is the strongest ligand, then amine, then aqua. So En is strong ligand mean its wavelength is less. So which one? Which one? En, they're asking increasing order of wavelength dear all. So H2O is the strong, then amine, then En. What is that? Option D is the correct answer. Option, yes or no? Option D is the correct answer. D. D is the correct, right? I hope you get the concept here all. En is a strong ligand. Stronger the ligand, stronger energy. Stronger crystal field splitting energy. Stronger, more the energy, least the wavelength. Least the wavelength. Okay, option D. Next question. Facial and meridional isomerism will be shown by. Come on fast. This is the third time they asking about FAC and mer isomer. Come on. Which will show FAC and mer isomerism? Quick. Which will show FAC and mer isomerism. Our time is very close to, we are going to wind up the session, but we have to discuss some more question all of you. If you give the correct answer quickly, we can go for the next question very fast. Yes, that is MA3B3 type is which one? MA3B3 type is FAC and mer, option A. Next one, which one has highest molar conductivity? Which one has highest molar conductivity? Dear all, this compound, there is no counter ion. It won't give no ions. No ion. How this will split? This is like our NaCl. This will give you CONH3 4 time Cl2 plus and Cl minus. It will give you total 2 ions. What about this one? K4FeCN6. I think 4K plus and FeCN6 3 CN6 4 minus. So dear all, this complex 4 plus 1 total 5 ions are producing. I think option C will be, and this will give you total 3 plus and 3 Cl minus. This will give you 4 ions total. Yes, option C is the one giving more number of ions. How many of them are given the correct answer? Yes, and Sabil, okay, already given the correct answer. Very good, all of you. Next one, which one will show optical isomerism? Can you say quick answer? Which one will show optical isomerism? Come on dear all, which will show optical isomerism? Very good, Venkata. Which one? Which one? Whether cis, trans or some other? Yes, most of them are giving the correct answer. That is option B, cis isomer. How to draw the cis isomer of this one dear all? CO, and it is an octahedral complex. We can draw like this. En, so Cl, Cl, En, En, right? This is the cis isomer. You know, cis isomer, when you take in the mirror image, it is not superimposable, right? It is not superimposable. They are optically active. Yes, cis isomer is optically active. Correct answer. Then the pair having the same magnetic moment is. Magnetic moment, I will show you another question here. Before that, can you tell me what is the answer of this? Those who know the spectrochemical series, can you say this answer first? Among the ligand amine, En, cyanide, carbonyl, what is the correct order of their field strength? What is the correct order of their field strength? Come on all of you, quick. Which is strongest ligand? CO, then cyanide, then En, then amine. I think option A, you all are given option A. Yes dear all, option A, CO is the strongest ligand. Spectrochemical series is a must area, must question you can expect. Okay, let's go for the another. Which of the following complex formed by Cu2 plus ion is most stable? You may study stability of the complexes depends on K value. K is called stability constant. Higher the K value, higher the stability. Can you say log K 11.6, log K 27.3, 15.4, 8.9. Higher the K value, higher the stability. I think you have an answer. What? Option B. Higher the K value, higher the stability, dear all. Higher the K value, higher the stability. Yes, Nima, Arnav, those who are taking seriously, yes, you are given the answer. Good all of you, and all the best for your examination. Definitely you will get the good marks for that one, those who are preparing seriously. Let me go for the last question for your exam. This is the question. Can you say what is the correct answer for this complex? 4 complexes are given here. Stabilization of coordination compound due to chelation is called the chelation effect. Which of the following is the most stable complex as per the chelation effect? You know, chelation effect is given by what? Chelation effect is mainly given by what? That bidentate or polydentate ligand. Check whether there is any bidentate ligand or not. Carbonyl not. Cyanide not. Yes, oxalate. Oxalate was what? Is a bidentate ligand. It can form what? Chelation, making more stability. Dear all, I want to give you one more question. One more question. Yes, dear all, tell me. We indicate the complex ion which shows geometrical isomerism. Come on. Come on fast. Which will show geometrical isomerism. Can you say fast? Can you say fast? Which will show geometrical isomerism. Geometrical isomerism. Geometrical isomerism. Yes, my dear students, given the correct answer. Option A. This is a type MA4B2. MA4B2 can show cis trans isomerism. MA3B3 show Fak and Mer isomerism that we studied in class. Atik Hemant already given the correct answer. MA4B2 type show cis trans isomerism. That is our geometrical isomerism. And tell me, dear all, the CFSC4. This is one of the specific question I want to tell you. The CFSC for octahedral complex is given. What is the CFSC of the tetrahedral complex? Here all, the CFSC of the tetrahedral complex, there is an equation 4 by 9 of which one? Octahedral. So 4 by 9 into, what is octahedral? They are already given 18,000. 18,000. So it's 2 times, it is 4 to 8,000. 8,000, option C. Please keep this relation with you, dear all. The CFSC of tetrahedral complex is equal to 4 by 9 of the octahedral complex. This equation please note in mind. 8,000 is the correct answer. I have to give you one more question. Already time is over. 5 minutes is exceeded. Sorry for that one. But maximum question should come to you. Another question. Due to the presence of ambidentate ligand, it is called, which isomerism? Directly you can able to say the answer. Come on. If there is an ambidentate ligand, see, SCN is there, NCS is there. What type isomerism it possesses? What type isomerism is possessed if it having a ambidentate ligand, dear all? That is what? Linkage isomerism. Very good. Linkage isomerism. Option A is the correct answer. And I am going for wind up this session with the last question for you. And tell me the answer fast, all of you. The compound. This compound shows what type isomerism? These compounds show what type isomerism? Very careful about this question. Very careful about this question, dear all. There is something special in this one. Those who are present online, come on. Option D, yes, no isomerism, because see here bromine, amine, SO4, cobalt. Here what? Chlorine, amine, sulfate, and what? Cobalt. See, bromine, chlorine, 2 different species are there. When they are giving isomers, you should be very careful whether they have same formula or not. Same formula or not. Okay, dear all. So I think almost the questions are going to over. Can you say the last question for your exam? Last question. Here I am going to wind up with the last question. I won't read the question. You read the question. Give an answer. Fast, quick. Okay, what is the answer for this question? Come on, all of you. Chelating agent has 2 or more donor atom to bind with a metal atom. Which of the following is not a chelating ligand? Which of the following is not a chelating ligand? That is what? Chelating ligand. Which one? I think you have a confusion. That's why I stopped with this question. Dear all, thiocyanato. What is thiocyanato? SCN. What is oxalato? Oxalato is, OX2 minus. And glycinato, you studied what is glycine as an amino acid, right? Glycinato, NH2, CH2, COO minus, glycinato. And ethane 1,2-diamine is what? EN. You know that oxalate and EN are bidentate ligand. Yes, we know. What about glycinato? Dear all, glycinato, this amine can donate, this oxygen can donate. It's also a bidentate ligand. Thiocyanato, SCN is a ambidentate ligand or a monodentate ligand. Option A is the correct answer. Question is what? Which of the following is not a chelating agent? Not a chelating ligand mean not a bidentate or polydentate ligand. Okay, dear all. So we completed lot of important area, and especially dear all, the last part, cisplatin, Wilkinson catalyst, the metal atom present in each system. You know, hemoglobin, iron is the metal atom, and chlorophyll pigment, magnesium is the metal atom, vitamin B12, cobalt is the metal atom. Those area also please revise it, and I hope you clear which all area you have to focus in coordination compound chapter. Thank you so much. I think 10 minutes we exceeded, so sorry for the delay, and please revise all these questions once again and make strong about your concepts and all. Okay, thank you all, thank you all, thank you all. Okay, dear all, good night. See you in the next classes. Okay, Nima, Satik. Okay. Thank you all, thank you, bye.